Take a look at that also in just a minute. The other day we talked about solving equations, but it was just solving, if you're given one equation, you had to solve for the unknown letter. But what if you had two equations that you had to solve or find the solution for? So that's where we're going to start today. And I want to go over the different type of possible solutions that you could have. If you are graphing or solving a system of equations and you get just one point of intersection, then that's actually the solution to that particular system. So if the lines, whether you're graphing them or using some other type of method, if they intersect at one common point, then that is the solution to that particular system. And by the way, it's hard to read here, but you would label this system as consistent, and also independent. So one solution that's known as consistent and independent. If your two lines are parallel, or if you work out a system by another method besides graphing and get a false statement at the end, something like 0 is equal to 2 or something similar, then, good morning. Good morning. Then that means that you have no solution. And that makes sense because if the lines are parallel, then that means they are never going to cross or intersect at a common point. So since they are parallel, or if you solve your system algebraically and get 0 equal to 2 or some other type of false statement, then there's no solution to the system. This would be labeled as inconsistent and still independent. Now, the third possible solution is if you graph two lines and they end up overlapping each other and they're actually the same line, or if you solve a system algebraically and you get a true statement at the end like 0 equal to 0, then there are known as infinitely many solutions. Because it's just one line, then all real numbers will work. So if you graph the two lines and they become 1, or you get 0 equal to 0 or some other kind of true statement, all these mean infinitely many solutions. And you will label this type of system as consistent and dependent. So those are the three type of possible solutions that we can have. Now, I want to go over a system with y'all in which you're given a solution and you want to verify if this solution is a true solution or not. So let's move over to this first problem. And let's just look at one of the order pairs. Let's test 3 and negative 12 and see if that is a solution to this system. So your x coordinate is 3, and your y coordinate is negative 12.
Thank you. You're welcome.
So everywhere that you see an x, just plug in 3. And everywhere that you see a y, plug in negative 12. Same thing with the second system. Now, in order for a solution to be a true solution to the system, it has to work for both equations. So right here we have 6 minus 12, which is indeed negative 6. So that checks out for the first equation. If we check the second equation, we get 3 minus 36, which is nowhere near 2. Because the solution did not work, the order pair did not work for the second equation, then we can say that 3 negative 12 is not a solution. Any questions from any of the campuses? And I'm cutting on my email as well as my text messages from my cell phone. So if the satellite campuses have a question and you don't want to ask it in class, that's fine. You can send me a text or email and I can answer it. I can answer it over the air here. Now, one method to solving a system of equations, as I mentioned, is graphing. So let's take a look at this first system here. And I'm actually going to use a website called Desmos. And I think I shared this website with y'all Tuesday, if I remember correctly. So I'll give you a second to copy down, if you need to, the system of equations. And we're going to solve this particular system by graphing. Okay, let me switch screens and show you the Desmos website. The cool thing about Desmos is that you can type in the system just like it appears on the paper. You don't have to solve for y like you would with a graphing calculator. So let's enter our first equation. X plus y is equal to 6. And let's enter the second equation, negative 6x plus y equal to negative 15. And I don't mind y'all ever using Desmos to check your own graphs in my math lab. So let's hide our equations. And where the two lines intersect, is your solution. So the system has a solution of the order pair 3, 3. If your system has a solution, then you must write it as an order pair. So our answer here would be the order pair 3, 3. Let's look at another system. And I'm just going to type this in. It's on the second page of your lesson 9 notes. The first the first equation is 9x plus 3y equal to negative 9. And the second equation is x minus 3y equal to negative 1. So when we minimize our system, and just hover your mouse over the point of intersection, and the order pair negative 1, 0 is a solution to the system. Any questions about solving a system through graphing? Let's look at another system. And we will, this system I'm about to type in, we will solve it algebraically later. But I wanted to show you what will happen now. The first equation is 7x plus 2y equal to positive 6. And our second equation is negative 14x minus 4y equal to negative 12. Now watch what happens when I type in the last part of the second equation. The second equation is in blue, but when I finish typing the equation, it gets superimposed over the first equation. So that is one of our special cases where the lines coincide or actually are the same line. So for this system, because they are, the two lines are actually one and the same, then your answer would be infinitely many solutions. So watch out for that if you are solving a system graphically and the two lines in the system become one. If that happens, then that means they're just one line, and your answer would be all real numbers or infinitely many solutions. Again, any questions about graphing before we talk about the next method? Okay, a second method you could use to solve a system is something called substitution. And substitution is exactly what you would do when you're trying to solve a system. You're taking one equation and plugging it into the other one. So let's look at number 3 to start off. A clue that you can use substitution is that in your system you have a letter already by itself. If you don't have a letter by itself, you may have to manipulate one of the equations to get a letter by itself. So what we're doing here is with substitution, because our second equation is y equal to this expression, 3x minus 10, we're going to take this expression and plug it into that first y in the first system, in the first equation. It's like this is a document or a sentence or something in Microsoft Word, and you're taking this expression and copying it and pasting it in place of y. So over here we have negative x minus 9 times 3x minus 10 equal to negative 22. And at this point, we just have to solve for x. So when we distribute the negative 9, negative 9 times 3x is negative 27x. And negative 9 times negative 10 gives you a positive 90. On the left side still, combine your x's. So that gives us negative 28x plus 90 equal to negative 22. We still need to get the x part by itself, but before we divide by negative 28, we must move the 90 to the right-hand side. So subtract 90 from both sides. And that gives us negative 28x equal to negative 112. The last step, divide both sides by negative 28. So part of our answer is x equal to positive 4. Before we go back and find the y value, did any campus have questions so far? Now, to find the y-coordinate, you can use either equation in the system, but I'm choosing the second equation because y is already by itself. So it's just simple plugging in to find y. So we have y equal to 3 times 4 minus 10. Therefore, y is equal to positive 2. One last thing you have to do is write your answer as an ordered pair. So our solution would be the ordered pair 4, 2. Again, any questions? Yes, sir, Warner Robbins.
Where are you getting the 4 from in the parentheses?
From the x coordinate. I just put it in alphabetical order. Oh, right here?
Right.
Oh, okay. Yeah, we just found x equal to 4. So in place of x, since we know it's 4, we just plugged that 4 in.
Okay.
Any other questions from the satellite campuses or here in Warner Robins? Let's look at another system in which you are solving by the substitution method. Number 4 has decimals and fractions, so it's probably a good idea to get rid of both. To get rid of the decimals, we just need to move each decimal point one place to the right, and that's the same thing as multiplying the entire equation by 10. So our new equation, first equation is 15x plus 5y equal to 0. Now, to eliminate the fractions, first identify the least common denominator. So the least common denominator would be 9 times 4, or just 36. You multiply the entire equation by 36. For the first fraction, 9 can go into 36 4 times, so that would be 4x. In the middle, 4 can go into 36 9 times, and that would be negative 9y. And the right-hand side is still 0. Now the directions say solve by substitution, so we don't already have a letter by itself like we did in question 3. So we have to pick an equation and get one of the letters by itself. I'm just picking the first equation at random, and let's solve for y for that first equation. So subtract 15x from both sides. So we have now 5y equal to negative 15x. And before we can use substitution, we need to get that y completely by itself. So we'll divide both sides by 5. So we got a letter by itself from one of the equations. Now we can use substitution. So all we're doing here is, in the second equation, where we see a y, we're going to copy and paste a negative 3x in that space. So we have 4x minus 9 times negative 3x equal to 0. Now, you guys know a negative times a negative is a positive. So that would give us a positive 27x. When we combine the x's, that gives us 31x equal to 0. So the bottom line is, when you divide both sides by 31, x is equal to 0. Before we find the y value, did any satellite campus or here in Warner Robins have any questions? Now, we found the x-coordinate. We need to go back and find the y value. So You could use one of the original equations, or probably better idea to use that equation because you already have y by itself. So in place of x, we'll plug in that 0 we just found. So y is also equal to 0. The last step, type your answer in my math lab as an order pair. So it would be the order, our solution would be the order pair 0, 0. Any questions, y'all, about the substitution method? The third method, as you see in the directions for the next batch of problems, is called elimination, or I think the book calls it the addition method. Let me go over what you need to do in order to use the addition or elimination method. Elimination method just simply means what it states. You pick a letter and you're trying to get rid of it in the system. So the criteria for using the addition or elimination method there must be the same term. You may have to multiply one or both of your equations by a common multiplier to get the x's or y's to be the same term. And they must have different signs in order to eliminate or cancel them out. For instance, the pair 2x and negative 2x, you have the same term, they're both 2x, but they have different signs where you can cancel them or eliminate them. So that's what I mean by same term, different signs. Let's look at number 5. Number 5, we have the system 5x plus y equal to negative 21, and 7x minus 3y equal to negative 69. Honestly, it does not matter which, with the addition method, which letter you want to get rid of. If I see different signs with the letter, then I'm going to pick that letter. So we're going to eliminate the y's somehow. Now with that first y, it's understood to be 1. We need to make this a 3, a positive 3, so we can cancel it out with the negative 3. So that means multiply the entire first equation by positive 3. So when we do that, we get 15x plus 3y equal to negative 63. Bring down the second equation. And now we can cancel out or eliminate the y terms. What you do with the rest of the problem is combine your x's and combine your numbers. So we have 12x equal to negative 132. The last step, divide both sides by 12. So our x-coordinate is negative 11. I'm sorry, I added wrong. Thank you for catching that. I think I was doing some weird subtraction and addition. You're right, it should be 22x. I apologize to all the other campuses. So we're actually dividing both sides by 22. So our x value is negative 6. Now, we need to go back and find the y value. You can pick any of the original equations, or even the modified equation if you want to use that. I'm just going to use the first original equation, just randomly picking it. Now, wherever you see an x, replace it with this negative 6 we just got. So we have 5 times negative 6 plus y equal to negative 21. And that gives us negative 30 plus y equal to negative 21. The last step to get y totally by itself is to add 30 to both sides. So the y-coordinate is a positive 9. The very last step, express your solution as an order pair. So this will be the order pair negative 6, comma, positive 9. Any questions about this system? Although these lectures are recorded, anytime you want to take a picture of work, you can pull out your cell phone and snap a picture of it. That would be fine. Let's look at a system where it's still going to solve by the elimination or addition method, but this next system contains fractions. First equation, x minus 1 over 7y equal to positive 6. And the second equation is negative x plus 3/4 y equal to negative 63 over 2. Now, you could go ahead and eliminate the x's and just combine the y's and the other fractions if you are comfortable with adding or subtracting fractions. Me personally, I want to eliminate the fractions, so I'm just working with integers. So to eliminate the fraction in the first equation, just multiply the entire first equation by 7. So we have 7x. In the middle, the 7's cancel, just leaving us with minus y. And then 6 times 7 is 42. Now, to eliminate the fractions in the second equation, first we find the common denominator. So the common denominator would be 4. So we'll multiply everything by 4 in the second equation. So right here, 4 times negative x will give you negative 4x. The 4's cancel in the middle, leaving you with a positive 3y. And at the end, 2 can go into 4 2 times. And 2 times negative 63 will give you negative 126. Now that the fractions are gone, we can pick a letter to try and eliminate. Well, it will probably be better to eliminate the y's, but you can eliminate the x's also and get the same correct solution. This is understood to be negative 1 in front of the first y. And I need that negative 1 to be a negative 3 so I can cancel it out with the 3y. So that means multiply the entire first equation by a positive 3. When we do that, we get 21x minus 3y equal to 126. And let's bring down the second equation. Before we eliminate the y's, does any campus have any questions so far? Now we can cross out the y's, they cancel, and combine what's left. So that will give us 17x equal to 0. When we divide both sides by 17, x is equal to 0. Now, to find the y-coordinate, you can use any of the 4 equations up here, the original bunch or the new pair. I'm using one of the new equations so we don't have to contend with fractions anymore. I'm just picking the second equation at random. And where I see an x, I'm going to replace it with 0 now. Here in Warner Robins and also on the satellite campuses, if you have a question and you don't want to ask it out loud, that's fine. You can certainly email or text me, and I'll be glad to answer it on the air. So we have 3y equal to negative 126. And last step, when we divide both sides by 3, our y value is negative 42. Make sure, y'all, when you express your solution as an order pair, that you put it in alphabetical order. So our solution would be 0, and negative 42. Excuse me. Any questions from any of the campuses? I'll give you a second if you want to snap a picture of this work and save it to your phone. While you're doing that, so far we've talked about two different ways to solve a system of equations. Graphing is one. We've talked about three now. Graphing, substitution, and the elimination method. Honestly, I don't care what method you use, regardless of what the directions say in my math lab. Whatever methods you understand best is what's important to me. Let's look at these special cases. Question 8, we have 7x plus 2y equal to 6, and negative 14x minus 4y equal to negative 12. It's a toss-up. You can choose to eliminate either the x's or y's because each pair has opposite signs. I'm just going to choose the x's to get rid of. Now, in order to eliminate the x's, this first number, we have to turn it from 7 into 14. Well, you just think, well, how much could 7 go into 14? Seven can go into 14 2 times. So that tells you what you have to multiply the entire first equation by, a positive 2. So we have now for the first equation, 14x plus 4y equal to 12. Bring over the second equation. Now, not only do the x terms cancel out, but also the y terms cancel as well. So if everything canceled out, then the left side is just 0. The right-hand side is also 0. Anytime you get a true statement like this, then that means that these two lines, as you saw earlier, remember when we graphed these two lines, they actually turned into one line. They coincided with each other and became one. So since it's now just one line, this system has infinitely many solutions. Any questions, y'all, about number 8 before we look at another special case? Let's look at one of the other special systems. Let's look down at number 10. Question 10, we have in the first equation, 1 over 10x minus 3 over 5y equal to 2 over 5. And the second equation, we have negative 2x plus 3y equal to positive 1. The first step before we decide what method to use is, in the first equation, eliminate the fractions. The least common denominator among the three denominators is just 10. So we'll multiply each part by 10. And along the way, we will cancel out to get rid of each fraction. With the first fraction, the 10s cancel, leaving us with just 1x. Second fraction, 5 can go into 10 2 times, and 2 times negative 3 will give us a negative 6y. And then at the end, 5 can go into 10 2 times, and 2 times 2 gives us 4. We didn't mess with the second equation just yet, so scoot it over. Now, probably elimination would be the best method to use. And because both pair of letters have different signs, it doesn't really matter which letter you choose to eliminate. Let's eliminate the x's. To eliminate the x terms, I need this one to be a positive 2. So that means multiply the entire first equation by 2. So that gives us now 2x minus 12y equal to positive 8. Bring down the next equation. Now we can get rid of the x terms. Cancel those out. And just combine your y's and also the remaining numbers. So we have negative 9y equal to 9. And with simple division, divide both sides by negative 9. We get y equal to negative 1. Now we need to go back and find the x-coordinate. I wouldn't use the first original equation because it has fractions. I'm going to use the first modified equation to find my x. Well, you could use that one before you multiply by 2. Where you see a y, plug in negative 1. So we have x plus 6 now equal to 4. And when we subtract 6 from both sides, we get the x coordinate x equal to -2. Our answer as an ordered pair is -2 and -1. Any questions about the elimination method? I want to go back to number 9 and tell you what happens. Number 10's answer was technically not a special case because we actually got an ordered pair for the answer. But I guess it was special because we had fractions to get rid of first. We had that extra step. Let's go back to System 9. And since I'm here live with the Warner Robins campus, I'll just ask y'all for suggestions. We're using the elimination method. Pick a letter for me to get rid of for number 9.
X.
Yeah, good choice. It doesn't matter really because both the X's and the Y's have different signs. Now, in order to eliminate the x's, that 2 has to turn into 4. So that means we have to multiply the entire first equation by 2. So we'll multiply the entire first equation by 2. And that gives us 4x minus 6y. And multiply the 7 also by 2. And that gives us 14 at the end. Bring down the second equation in the system. As expected, the x terms now cancel, but the y terms also cancel. So on the left side, we're left with 0. Be careful, the right side numbers do not cancel. They actually sum to give us 28. Y'all, anytime you get a false statement at the end for a system of equations, then you know there is no solution. In just a second, I'm going to switch back to Desmos and show y'all graphically why this system is no solution. Any questions about this particular problem before we graph the system? All right, I'll leave it up here while I type in the system into Desmos, and then I'll switch over to the computer so you can see what happens. All right, our first equation has already been typed in. And let me type in the second equation. Well, you see right away why this system has no solution. The two lines are parallel. And you guys know if the two lines are parallel, they will never ever intersect at a common point. So graphically, we've proven that the system has no solution. Any questions about lesson 9 before we look at lesson 10? Okay, lesson 10 is word problem applications. So let me find my notes and we will go over some of these word problems. We probably won't go over every single word problem, but we'll go over a good majority of them. Let's start with question 1. A lab technician mixed a 590 milliliter solution of water and alcohol. If 3% of the solution is alcohol, how many milliliters of alcohol were used and how many milliliters of water were used? This is not a system of equations per se. You can actually solve this with basic math. So alcohol is 3% of 590. Now, before you solve this or plug it into your calculators, change the 3% into a decimal. That's like our sales tax. I know I'm making the sales tax is 7%, and that's the same thing as 7 cents on the dollar. So 3% is the same thing as 0.03. So the amount of alcohol used is 17.7 milliliters. Now, to find the amount of water used, it's just simple subtraction. You take out the amount used for alcohol, subtract it from the 590. So 572.3 milliliters of water were used. So you'll see a similar question like this in the lesson 10 homework, in which you don't need a system of equations. It's just regular arithmetic. Question 2, I'm actually skipping because, well, I can tell you the correct answer. There's really no work involved. How much will C pounds cost? The correct answer is 0.51 C. You're multiplying, that's it. So 0.51 times C is how you would express in C pounds. And that problem will actually help you with some problems toward the bottom of the page. Number 3, we're not solving this, we're just setting it up, and it will help us with a future problem. If the rate of the boat in still water is 31 miles per hour, and the rate of the current of a river is X miles per hour, what is the rate of the boat in each case? The boat is going upstream. Well, you guys know if you're driving up the hill, you're probably losing speed. So losing speed means subtraction. So that particular rate of the boat would be 31 minus x. Part B, the boat is going downstream, that is with the current. So if you're going downhill or downstream, you know that you're gaining speed. You're going with the current. So gaining speed means addition. So the rate of the boat would be expressed as 31 plus x. Again, this will help us with future distance, rate, time problems. Any questions, y'all, about the first three problems? Okay, question 4. A basketball team played 51 games and they won 19 more than they lost. How many games did they win and how many games did they lose? We're setting up a system of equations. We'll let x equal to the number of games won, and we'll let y equal to the number of games lost. Now, together with the one-loss record, the basketball team played 51 games. So together means addition. So our first equation is x plus y equal to 51. Now the second equation says, the second equation will be from the second sentence. They won, which is x, equal to 19 more, which is plus 19, more games than they lost. And we know the number of losses is represented by the letter y. Any questions how we got the system before we pick a method to solve it? Again, since I'm here live with Warner Robins, what method would y'all prefer using? Substitution or elimination? Substitution is a good choice, because we already have one of the letters by itself in the second equation. So what we do is, in the first equation, where you see an x, copy and paste the y plus 19 in it. So we have y plus 19 plus y equal to positive 51. And we just solve for y. Combining the y's on the left side gives us 2y plus 19 equal to 51. And the next step, subtract 19 from both sides, leaving us with 2y equal to 32. So the number of games lost when we divide by 2 is 16 exactly. Now, you don't have to really substitute 16 for y in the second equation, you already know that they won 19 more games than they lost. So that's just simply 19 plus 16. So the number of games they won was 35. If you get a negative answer with this type of word problem, check your setup at the beginning with your system. Any questions about number 4? In my math lab, it will probably ask for 2 answers. You may have multiple parts to answer. So make sure you answer all the questions being asked. Okay, number 5. The perimeter of a standard size rug is 44 feet. The length is 2 feet longer than the width. Find both the length and the width. The first step is to figure out what formula to use to build our system of equations. Because we're given a rectangle, well, technically, yeah, a rectangle, we use the perimeter formula. P is equal to 2L plus 2W. We can go ahead and plug in 44 for the perimeter, or P. Now we need to get the second equation in our system. It says the length, or L, is, which is our equal sign, 2 feet longer, which means plus 2, than the width, or W. I think with this system, I'm going to go by your recommendation of Warner Robins and use substitution again. All we do with substitution is you take W plus 2 and plug it into the first L in your first equation. So we have 44 equal to 2 times W plus 2 equal to, plus 2W at the end. And we're solving this equation for the width. So we have 44 equal to, when we distribute that 2, that gives us 2W plus 4 plus 2W. Before we solve for the width, we have to combine the W's on the right-hand side. We now have 44 equal to 4W plus 4. Also, if you get a negative answer with this kind of problem, you know that your setup is wrong, because y'all know that length and width has to be positive. Back to our equation, let's subtract 4 from both sides. Leaving us with 4W equal to 40. And when we divide both sides by 4, Our width is 10 feet. Before we find the length, any questions about what we've done so far with number 5? Now to find the length, you can just eyeball it and say, well, the length is 2 feet more than the width. 10 plus 2 gives us 12 feet for the length. So we got both dimensions. Again, from any campus, any questions about number 5? I'll give you all a second to take a picture of the work if you want to. Again, if you get a negative answer, you know that's not possible with a geometry problem, regardless of the type of figure that you're given, be it a rectangle, square, triangle, whatever. The dimensions of size have to be positive. All right, let's look at question 6. A baseball team has home games on Friday and Sunday. The 2 games together earn $3,177.50. Actually, I'm going to skip down to number 8. Number 6 is a view an example question in the homework, so you can view the steps. I got every question from that view an example tool. I want to jump down to number 8. Because with number 8, you probably have, you could if you want to, you may have to use a table or not. Number 8, cornmeal is 6% protein. Soybean is 10% protein. How many pounds of each should be mixed together in order to get a 240-pound mixture that is 8% protein? First of all, label your given information. We'll let X equal to cornmeal and Y equal to soybean. To get our first equation, we know that if we mix these, without the percents just yet, if we mix these two together, they should add up to 240 pounds. So that's our first equation in the system, X plus Y equal to 240. Now the second equation in our system is where you use the same equation as the first one, but you incorporate the percents now. With the cornmeal, that's 6% protein, or 0.06x. The soybean is 10% protein, or when you change the percent to a decimal, that would be 0.10y. And we're adding these different percentages to get an 8% protein mixture. So we have the 240 still, but we have to multiply it by 8% to get the desired mixture. uh, or same thing as 0.08. Any questions about our system? Now we need to clear the decimals in the second equation. So each, the greatest number of decimal moves will be two spots to the right for each decimal. So that's analogous to multiplying the entire equation by 100. So we'll times the entire thing by 100. So that gives us 6x plus 10y. And I'll go ahead and tell you, when you multiply 240 times 0.08 times 100, that gives you 1,920 on that side. Let's bring down the first equation. And you can either solve this, it will be about the same amount of steps, by substitution or elimination. I'm going to use elimination this time around. Now, in order to eliminate, let's say, the y's, this number right here in front of the second y, it has to be a negative 10. So that tells us we need to multiply the entire second equation by negative 10. So let's scoot over the first equation. And when we multiply the second equation by negative 10, we get negative 10x minus 10y equal to negative 2,400. Now we can eliminate or cancel out the y terms and combine everything else. So this would be, when we combine the x's, negative 4x equal to negative 480. And when we divide both sides by negative 4, we get x is equal to 120 pounds. Before we go back and find the amount of soybean needed, any questions how we got the amount of cornmeal? So we know the amount of cornmeal is 120 pounds. Well, you can find the amount of soybean pretty easily. We know if cornmeal is 120 pounds, then that means soybean, we also need 120 pounds to equal to 240. So the amount of soybean is also 120 pounds. Again, any questions, y'all, about number 8? Let's go back up to number 7, another geometry problem. Question 7, find the measures of the angles marked X and Y. Remember that 1, the sum of the measures of a triangle is 180 degrees. And 2, supplementary angles, in other words, 2 angles that when they're side by side, they form a straight line. Supplementary angles have a sum of 180 degrees. So from this information, we can build our system of equations. Let's use the first tidbit. It says the sum of the measures of the angles of the triangle is 180 degrees. So that means x plus y plus 90 is 180 degrees. Now let's get x and y by itself by subtracting 90 from both sides. So our revised first equation is x plus y equal to positive 90. The second equation, use the fact that supplementary angles, when you add them together, equal 180 degrees. So that will be 2x plus 35 plus y equal to 180 degrees. Again, just like we did with the first equation, let's get x and y by itself. This time around by subtracting 35 from both sides. So our revised second equation is 2x plus y equal to 145. Now, before we pick the method we want to use, any questions, y'all, about the setup? You could use substitution to solve this system. I'm going to rely on elimination because for the y's, they have the same term, but we need them to be opposite signs. So one of these y's has to be negative in order to cancel them out. It does not matter which equation you multiply negative 1 by. I multiplied the first system by negative 1. The first equation, I'm sorry. So down here we have now negative 1x minus 1y equal to negative 90. Bring down the second equation.
Hey, excuse me, Mr. Arnold.
Yes.
This is Macon. I have a question. Why did you do negative 1 for x plus y equals 90?
Right. You could actually, we got to, probably the best thing to do is I can eliminate the y's because they're already the same term.
Oh, okay.
But in order to get rid of them or cancel them out, one of these y's has to be a negative number. So it doesn't matter, honestly, which equation you multiply negative 1 by. I just chose the first equation randomly.
Okay.
Did that answer your question, sir?
Yes, sir, it did. I had just missed it. I thought you were doing x, and that's why I got it.
Okay. Now the y's can cancel. And when we combine the x's, that would just be x. And over here, when we subtract 90 from 145, excuse me, that will give us 55 degrees. Now we need to find the angle y. Yes.
Instead of multiplying the person by -1, could you just subtract it?
Technically, you could. You should get the same same result. Now you can plug in 55 up here for x, or you can just eyeball it again because you know that the two angles have to equal 90 degrees according to this equation. So we know that the other equation is, the other value is 90 minus 55, or y is equal to 35 degrees. Again, any questions about the setup or the solving part? Okay, I want to go over a rate problem with y'all. Very similar to number 3, as far as setting it up. Let's look down at number 10. In his motorboat, Bill Rumberg travels upstream at top speed to his favorite fishing spot, a distance of 182 miles in 7 hours. Returning, he finds that the trip downstream, still at top speed, takes only 6.5 hours. We need to find two things here. The rate of Bill's boat and the speed of the current. And for this particular problem, the problem tells you what to let x and y be. It says let x equal to the rate of the boat in still water and y equal to the rate of the current. Now the main formula that we'll be using is rate times time equal to the distance. Now, anytime that you are working with rate, time, or distance, or even if you're mixing stuff together like candy, like in number 11, you can use a table to set up your system. So let me draw a table. And the first column is how he's traveling, be it upstream or downstream. Up here at the top in our headings, we plug in rate, time, and that's equal to distance. Now, we know the rate of Bill's boat is represented by the letter X. Now, if he's going upstream, then he's going against the rate of the current. So if you're going against the current, that means you're losing speed. And you guys know losing speed means minus. On the way back, he's going downstream with the current, So that means he's gaining speed. So we can represent that particular rate going downstream by x plus y. Now we know the time for each trip. The time going upstream, it took 7 hours. And coming back down predictably took less time, 6.5. Now, how we get the last column is we just follow the original formula, where we're taking each rate and multiplying it times each time. So distance represented for upstream is 7 times x minus y. And the distance going downstream is represented by the expression 6.5 times x plus y. Now, before we use this information to get our system of equations, any questions, y'all, about the table? Now, let's use this information to build our system. Upstream is 7 times x minus y. Downstream is represented by 6.5 times x plus y. Well, our system is incomplete because with a system of equations, we must have these two expressions equal to something. Well, regardless if Bill went upstream or downstream, the distance both ways was 182 miles. So that's what we set each equation equal to. Now, to make it a lot easier on us, for the first equation, let's divide both sides of that first equation by 7. Right here, the 7's cancel, leaving you with just x minus y equal to 26. And do the same thing to simplify the second equation going downstream. Divide both sides of the second equation by 6.5. Right here, the 6.5's cancel, leaving you with x plus y. And when we divide 182 by 6.5, that gives us 28. Any questions about what I did to modify the system? I just did that honestly to make it easier to solve the system. Warner Robins, I'll ask you guys again. With this system, we can use elimination, of course. What letter would you prefer? Why did you pick Y? Okay, good choice. Good answer.
Go ahead and cancel it out already.
Right. There are different signs for Y, so you can go ahead and cancel them out. But going back to what you said, yeah, sometimes you might want to pick a different letter, but you'll get the same answer at the end. So the y's automatically cancel, and we have 2x equal to 54. Divide both sides by 2, and x is equal to 27 miles per hour. According to our labeling, that is how fast, that's Bill's boat, his rate of speed. Now to find the rate of the current, you can pick one of these two equations in red. I'll just pick the second one randomly. And place of x, plug in 27. Well, when you divide both sides by, I'm not meant division, I'm sorry, I mean subtraction. When you subtract 27 from both sides, that is the rate of the current. Now, if you get for the current, the rate of the current, something like 787 miles per hour, Bill is traveling, isn't he? If the current here, you got the rate of the current was something like 787 miles per hour, yes, Bill is quite fast. Okay. All joking aside, that tells you right away, wait a minute, I did something wrong. Let me go back and check the setup in my table. So you should get, just like in real life, you should get answers that are reasonable. Any questions before we look at one more example? All right, let's look at the last problem, number 12. Tickets of a program at college cost $6 for general admission or $5 with a student ID. If 181 people pay to see a performance and $977 was collected, then how many of each type of ticket were sold? So tell you what, we have to label our given information X and Y first. So we'll let X equal to the general admission tickets. And we'll let Y equal to the student ID ticket sold. Now together, 181 people bought tickets. So together just means addition. Our first equation in the system is the general admission tickets plus the student ID tickets, and that's equal to 181 tickets sold. Now, to get the second equation in our system, This is where you include the money part of it, the cost. General admission tickets cost $6, so we can represent that as 6x. To pay for, with a student ID, the tickets cost $5 a piece, so we can represent that as 5y. And altogether, $977 was collected. So that's what our second equation is equal to, 977. Now, probably best to solve this system by elimination. And I'm just going to randomly, well, not randomly, according to my notes, my math lab eliminated the y's. So to eliminate the y's, that means this first number in front of the y must be a -5. So we'll multiply the entire system by, the entire first equation by -5. So that gives us -5x minus 5y equal to -905. We didn't do anything with the second equation, so scoot it over. Now we can cancel out or eliminate the 5y's. If you had chosen the x's, you'll find the y value first, but you'll get the same correct number of tickets. So when we combine what's left, we end up with x equal to 72. And that is the number of general admission tickets sold. I'll go ahead and tell you, I hear the fire alarm going off. Y is equal to 109 for student ID. Is that in Macon that the fire alarm's going off?
Yes.
Okay, y'all need to go, leave now. Go outside, okay? Take your stuff, go outside now. For all campuses, the video should be uploaded later today in Blackboard. And I want to wish everybody a wonderful weekend, okay? I think I've heard it all within these last few weeks. Vacuum cleaner, train, and now the fire alarm's going off. Welcome to the world of technology.
Your meeting has ended.